The United States is a nation of drivers. Unfortunately, we're dependent on foreign oil to fuel our vehicles. Last year, we imported 2.8 billion barrels of oil, much of it from the Middle East. But there are alternatives. New technologies now make domestically sourced natural gas a viable transportation fuel. Natural gas is abundant, burns cleanly, and can help bring energy independence to the U.S.
We are sitting on top of one of the world's largest natural gas deposits. In fact, the U.S. has been nicknamed the Saudi Arabia of natural gas because we have so much of it here.
So, what's the holdup? Before natural gas can become an everyday fuel for cars, safe and practical fuel tanks need to be designed and tested. Some commercial vehicles already run on natural gas, but require bulky and expensive compressed natural gas tanks.
Natural gas is used quite a bit in the United States, especially for long-haul trucking. It's used in fleet vehicles like buses, places where the vehicles know where they're going to be and the fueling stations can be set up so that there can always be there when the vehicles need to be refueled.
Compressed natural gas may work for a bigger vehicle, but what about light-duty and passenger vehicles? Large, pricey, high-pressure tanks just aren't consumer-friendly.
Fitting a long tube in a passenger car means changing the architecture of the car, which can be a huge hurdle because I like having trunk space. I like having a spare tire, or I like actually having most of my back seat for people.
Researchers are now looking at less expensive, low-pressure tanks utilizing adsorbed natural gas. Inside an empty tank, natural gas molecules tend to repel each other, but are attracted to surfaces. Aeng tanks are filled with adsorbent materials. At a molecular level, the crystalline structure of adsorbent materials contains trillions of identical pores that attract the gas molecules and greatly increase the available surface area for gas storage.
The best way to describe it is literally a sponge. So this material, through energy, it actually physically will grab a molecule of natural gas and hold on to it.
The result is smaller, safer, conformable tanks that can store larger volumes of gaseous fuel. It's not as simple as filling a tank with adsorbent materials, though. Cost and mass of the adsorbent are issues, and the temperature and pressure inside the adsorbent tank needs to be regulated to optimize fuel capacities and engine delivery. Savannah River National Lab is investigating new and novel methods of controlling the temperature of these adsorbent systems.
As gases are stored onto a solid, they go onto the solid and they stick to the solid, and energy is given off at that point in the form of heat. And so the material will eventually get warmer as more and more gas sticks to the surface. So we use what's called temperature-assisted pressure swing adsorption.
And with temperature-assisted pressure swing, we drop the temperature as we're increasing the pressure in order to get the maximum amount of storage. And then using an intelligent control scheme, we'll start dropping the pressure slowly in order to get some of the gas off. And then once we get to a minimum threshold pressure, we'll then start increasing the temperature. And in that way, we have the maximum storage at a colder temperature, higher pressure, and the minimum heal, the minimum unusable gas at a higher temperature and lower pressure. And in doing that, it allows us to really get the most use out of the adsorbent.
Using process intensification, Savannah River National Lab scientists are investigating light, inexpensive, adsorbent materials compatible heat exchangers made from prefabricated aerospace products.
It's a hexagonal aluminum sheet that actually is glued together and then pulled apart. So it is excellent as far as thermal conductivity. Aluminum has a great heat exchange rate, and the other advantage is that it's very thin, so it's very light. And then on top of it, it takes up less volume, so that means you can actually put more of your material, your absorbent that's going to hold the gas, into your tank itself.
Savannah River National Laboratory, a recognized leader in gaseous research and development, is now taking adsorbent materials out of the lab and onto the highway.
We understand the thermodynamics and the physical characteristics of the material. We modify those characteristics to meet the automotive demanding systems that need to be built. And we're developing new systems to meet these new materials.
Comes down to economics. If you could drop the price of the actual tank, and then of course all the subsequent components that require, the idea is that the car companies now will find it attractive. There is the potential of it being quite a significant impact on a total global scale.
There is a finite amount of gasoline on this planet. And then you add to that the fact that natural gas is about 1/5 the cost of gasoline. And now suddenly it makes economic sense. From a national security standpoint, it helps our country. And it also helps us from an environmental standpoint as well. So when you add all those factors together, natural gas really makes sense as the next step in energy independence, as well as the next step when it comes to environmental issues.